Okay, good day. I'm here, Francis Joseph Serino, to talk to you about pointers and arrays in C++. Okay, let's begin by creating a C++ code demonstrating how arrays work. So just a recall, remember that arrays are complex data types to store multiple variables of the same data type. Remember that the declaration goes something like this. You have your data type, followed by your array name. Inside your index operator is the size, and then you can give it initial values. Remember that the size or the initial values can be omitted, but you're not allowed to omit both of them. Either of them should be given. Now in memory, the variables inside your array are contiguously allocated, meaning they're side by side. Let's have an example. Let's say I have a character array called R with a size of 5 elements. How does that look like in memory? So you have your array. So I have 5 elements, where the first element and your second element is here. And your last element is here. So notice they are side by side. That's actually how the computers store the variables inside your memory. Okay, now let's discuss pointers with arrays. Let's say you have an integer array. So with a size of 5 and initial values 1, 2, 3, 4, 5. We can print the first element by cout 0. And that will give us 1, which is the first element. Now what if we printed out the array R without the index operator? What is it going to output? Why don't we try that? So let's open up my terminal. So here's my code. Just make sure. Yep, that's the code. If you run that, tada, you get some, whoa, what is that number? Totally does not make sense. Let's find out what this thing, this data here, actually means. To help us find out what that does, I'm going to output the addresses of all the elements of my array. Notice I'm just outputting the addresses of all my elements. Compile, run, and notice that this one is actually the same as this one. And this is actually the address of the first element. So what does that mean? In C++, the array name contains the address of the first element. Which simply means that arrays are actually a special type of pointer. Why special? Because normally a pointer, you can change whichever variable it's pointing to. However, in arrays, you cannot do that. It is a pointer, but it only points to the first element. But that's it. You cannot change that. So conclusion there is, arrays are actually pointers in C++. Now let's move on. Let's talk about pointer arithmetic, or applying algebra or addition and subtraction on pointers or the addresses. So let's try this code. I'm going to create a character array called x with a size of 5, no initial values. I'm going to create a pointer called px, character pointer, that will point to the first element of the array, which is x, or inversely we can use the address of the first element. Now let's demonstrate how this works. In this line, I'm incrementing the pointer by 1. What does this mean? To compare, I want to show you the addresses. Let's output addresses of the elements of the array. All right, nice. So I'm outputting the address of each element. Let's run this program. Let's compile and run. Okay, what happened here? Notice that the first element is located here, which is also what the pointer is pointing to, px. When the pointer increments by 1, it goes to this address, which is also the address of the second element. Notice the last digits here, 73, 74, 75, 76, 77. So these are the addresses. Actually, this the whole thing is the address of your of the array, and these are actually the addresses of each element. So let's say, theoretically, let's say my x is theoretically, this is my array x, is located at address 100 in decimal. So the next element should be located at 101, at location 101. The next element, the third element, should be located at address 102. The fourth element should be at 103, and finally the last element should be at location 104, which makes sense. They're contiguous, as you can see here. Now let's change these data types. Character, let's change that to a short. So that's the only thing I changed. I changed these two from character to short. Now let's run that. Compile, run. Oh, now what happened here? Notice that it's actually incrementing by 2. 6e plus 2, that's 70. This is in hexadecimal, by the way. 72, 74, 76. Which is actually still the address of the first element, the second element, the third, fourth, fifth element. So if you notice, it actually always points, the first element points to the first element, but it increments by 2. But notice that we're actually just incrementing the pointer but by 1. Meaning, let's say, now that x is a short, the first element will be located at location 100. And seen here, the second element is 2 spaces or 2 locations after the first element. So this is going to be the location of the second element. And the third element will be located here. The fourth element at 106. The last element will be at location 108. Now the question is, how come I'm incrementing my pointer only by 1, yet I am going to the next element? Let's try a different data type. Let's try integers. If I change that to an integer, compile, run, and notice that the differences between the locations are now by 4. So if I'm using an integer, so let's say x is located at location 100, the next element is going to be the second element in the array will be located at 104. Then the next one located at 108, and so on. But remember, we're only incrementing the pointer by 1. So what does this mean? Incrementing a pointer by 1 or plus plus for pointers does not necessarily mean you're increasing the address by 1, but rather it means you're going to the next element. Okay? Let's try that with another data type. So if you've noticed, for the short, so this is for character, this is for char, which is just 1 byte. So if you notice, it's separated by 1 byte each. Then you have your short. Then you have your int. That's because in my computer, integers are 4 bytes. Shorts are 2 bytes. Let's try to go to the next longer one. Long. So if you compile that and run it, notice that the difference, the locations, are now 8 bytes apart. So if I'm using a long, location 100, the next element is at location 108. And the next one is at 116, or in this case, this is in hexadecimal, it's the next. So it's from 50 to 58 to 60 to 68 and then 70. Remember this, plus plus for pointers doesn't necessarily mean you're increasing the address by 1, but rather you go to the next element. The compiler automatically determines the next element based on the size of the data type. Now let's leave x at int, okay? I'll just use int. If we can try incrementing, let's try decrementing. So I'm going to set px to point this time to the third element of the array. So x plus 2. You can also use address of the third element. Either way will work. This will work because I am moving to the next element and then to the one after that. So it's 2 elements after x. The compiler will automatically know how many bytes that is based on your data type. Okay, if we decrement this pointer by 1, px minus minus, and then we try to output, my question here is, where is px pointing to now? Okay, let me repeat. Px is now pointing to the third element of x. I decremented the pointer, so that's decrement, so decrease by 1. Question is, where is it pointing now? Let's compile and run. Oops. Let's have a separate end line here. Okay. So this is your first element, 64. Second element, 68 there. So now it's pointing to the second element. So you can see that there. So from the third element, you decrease by 1. Now the second element. So similar to your plus plus or your increment, decrementing for pointers means go to the previous element. Let px point to an element outside the range of our array. So if you notice here, our array, integer array called x, only has a maximum of size, a size of 5. But this time, we're going beyond that range. So technically speaking, this is what we call out of bounds, beyond the range. And then, we try to change that element located at some place to 100. And let's print that. Cout. what is going to happen. So let's compile that and run. Okay, notice here I have an error, segmentation fault. I don't know what this number represents, but I encountered a segmentation fault. So a segmentation fault is actually quite complicated. For now, let's leave it to a short definition of trying to manipulate data beyond the range of your variable. So I'm trying to access a part of the memory that doesn't belong to my program. That's also known as access violation. There's actually a segmentation fault is actually bigger than that. There's more to it than just that. But in our case, let's simplify it to trying to manipulate data beyond our range. So it's the segmentation fault. So it's an error. Okay, so I'm going to comment that out so that we can continue. I want to differentiate the dereference operator and the index operator. So I want to reset my pointer back to the first element. And we can change the third element of x using two different ways. Using px. We can either dereference px plus 2 is equal to 10. So that's the third element. Or we can use the index operator and set that. So what does this mean? What I just want to point out here is that this dereference, your pointer, and this, using the index operator, are actually the same. In fact, the compiler, when it sees this, it will automatically do this. This also explains why arrays, the array indices, start with 0. The first element, px, the array is already pointing to the first element. So px plus 0 is the same thing as dereferencing px, which is the first element. Now take note of where you're putting your parentheses, because if you did not put your parentheses and you have something like this, this is going to cause an error. Why? What's going to happen? Let's try this. Okay. The L value required is left up. The left hand side of your assignment operator is supposed to be a variable. What happens here is that you dereferenced px, so I got the first element, the variable at the first element. I added 2 to that, so it's a value, and then I assigned 10 to that value, which is not allowed. Assignment operator requires that the left hand side should be a variable. So this is going to cause an error. Okay, let's do something insanely ridiculous and completely useless. Let's make the pointer point to the fourth element. So this is how we point to the fourth element. Or you can use the address of the fourth element. I prefer using this because you only have 2 operations. Just the pointer arithmetic, the addition. Here you have 2 operations. You have the index operator and then you have your reference operator. So I prefer to use the one on the left. Now let's use a negative index. Px negative 2 is equal to 20. What element did I just change? Let's output the data of all our elements. Notice what I have changed here is the second element. That we can solve that algebraically because remember that this statement can be changed to px minus 2 is equal to 20, which is allowed since px is originally x plus 3. So we can substitute that. X plus 3 minus 2, that's the same thing as x plus 1, or that's the same thing as x1 is equal to 20. So this statement actually changed the second element. Now you don't normally do that for integers, but that is done for character arrays, but we won't go there. So just a summary. Array elements are contiguously allocated in memory. Arrays are pointers pointing to the first element. Incrementing a pointer by 1 goes to the next element rather than literally adding 1 to the address. Decrementing a pointer by 1 means going to the previous element rather than literally subtracting 1 from the address. Segmentation faults are caused when your program tries to manipulate a location beyond the scope of your program. And the index operators and the dereference operators are nearly the same. So that's for today, arrays and pointers. I hope you understood all that. Our next topic would be pointers with structures. Hope you enjoyed. Good day.